Hi everybody, and welcome to the second part of LokiBot analyzing video series, spoofing GULoader and LokiBot command control server part 2, this time INetSim and Burpsuit. In principle, this is very similar to the previous part. If you missed that, you can check it on YouTube too, where we basically do the same, spoofing GULoader and LokiBot command control server, but with our own implementation in Python. So it required Python scripting and other stuff. It was more difficult and more time consuming, but this time we will be using very reliable and useful tools in INetSim and Burpsuit. So for this exercise, or to repeat myself from the previous part, why we are doing this, basically now the command and control server for of GULoader and LokiBot is already down, and I already have the encrypted LokiBot payload, which will be served from the GULoader command and control server. So basically, I want to emulate or do the simulation of the command and control server behavior. So this is why we are doing the spoofing GULoader and LokiBot command and control server. In this exercise, I'll be using two virtual machines, and one is Windows virtual machine as a victim, which gets compromised, and the second one is Remnux. Remnux is a very well-known Linux distribution. This Linux distribution is pre-built and prepared for malware analysis and reverse engineering. Remnux has also built-in already installed tools in INetSim and Burpsuit we will be using in this exercise. If you want to check more information about all of this I will be doing, you can check it here. Some of the information are mentioned in this article, so you can check it and read it. This walkthrough is available on my GitHub page, and this link to this GitHub page will be available below this video. So basically, Windows VM will be our victim, and Remnux is a default gateway for the Windows VM. So on Remnux, there will be running INetSim and Burpsuit. And why? Basically, INetSim is very good tool, one of the most reliable for simulating network services, like for example DNS, HTTP, HTTPS, SMTP, FTP, and other stuffs. It enables you to also specify payload, which will be served, for example, as if somebody will perform the HTTP request, you can specify the response payload for this HTTP request and other stuff. Basically, it has a very nice built-in configuration file where you can modify many things. I will show later the most important ones for this exercise. And Burpsuit, we'll be using Burpsuit because Burpsuit is again well-known tool, usually used for penetration testing, but it has also features and capability of capturing web traffic, so something like proxy, web proxy server. So basically, Burpsuit is able to listen for HTTPS and HTTP traffic, and I chase Burpsuit to use Burpsuit and not, for example, Fiddler or Zap proxy and other proxy solutions, because Burpsuit has two very good capabilities. One of these is that for TLS, it is able to generate certificates on the fly according to the requested host. And redirect this web request to the INetSim. So it's very useful. You can imagine that I can request, for example, HTTPS request, so via TLS, to, for example, google.com, and Burpsuit is able to generate the certificate for google.com on the fly. And after that, I will try to connect to github.com, and Burpsuit is again able to generate the certificate for github.com on the fly. These certificates generated on the fly are signed with the CA certificate from Burpsuit, And this Burpsuit certificate has to be imported to the, for example, our virtual machine, the Windows VM, the infected one, and it has to be imported as a trusted root. And after that, all signed certificate with this certificate, authority certificate, will be trusted. So basically, very useful capability or option from Burpsuit. And another one why I'm chased to use Burpsuit is that it has very nice feature. And this feature is called invisible proxying. What is invisible proxying? I will explain later. It's very important, and basically it explains how the proxy and web traffic, proxying web traffic, how does it work. So next, for INetSim, the serving encrypted payload, we will be serving the encrypted payload as a response to HTTPS request, and the encrypted payload is here. It's basically already downloaded from the GULoader command and control server, and it's here encrypted LokiBot. You have to use it because the command and control server of GULoader is already down, and LokiBot command and control server is already down too. So basically, this is very nice exercise here. So to read a little recap, network IOCs for this exercise: drive.google.com is a command and control server or a server for which serves for downloading the encrypted LokiBot. GULoader will try to communicate to drive.google.com and download this payload. After that, this payload gets decrypted and run. And after the LokiBot will be running, it tries to communicate to command and control server of LokiBot to this direct IP web connection. So that's all for the little intro, and we can jump to steps. So first of all, we need to configure the Remnux, INetSim, and Burpsuit, and after that we have to configure Windows. The Remnux will be much harder and more time-consuming, but I will show you. So first of all, we can jump to Remnux, and we need to enable rerouting all external IP address to the local host. Basically, we need to say Remnux to be able to redirect this IP address, the external one. Basically, LokiBot will try to communicate to this IP address, and Remnux as a default gateway has to be able to redirect this external IP address to localhost. So for this purpose, you have to run these commands here. I will explain it why. So first of all, this one, let's sudo we just jump to the Remnux and paste here the first command. This command will basically enable to redirect external IP request to our local host. The second one command will be doing something different, and basically this command, with this command we are able to doing the pre-routing. So if our Windows VM will be trying to communicate to some external IP address, the external IP address will be pre-routed, and in this case also the external IP address has to the Windows VM has to communicate to destination port 80. So if the external IP address and destination port is 80, it will be redirected to localhost port 80. And we can do this pre-routing because we just enable the option to pre-routing external IP address to local host. So these two commands are very important and necessary. To be able to use INetSim DNS Server Simulator, you should disable systemd resolved as this will conflict with INetSim. What does it mean? Basically, this service is running on your Remnux or Linux distro if you have Ubuntu or something like that. So basically this service is listening on port 53, and we need this port 53 to simulate the DNS server. The INetSim needed, so it will collide, so we need to stop and disable this service. For that purpose, I already prepared here two commands. First and second one, just jump back here and paste the commands and stop the service. This one will disable the resolving service and the DNS resolving service, and the second one will stop the service. And I think that's maybe all. Jump back. Yep, and now we can jump to, this was basically settings for Remnux. And now we have to change the settings for INetSim. So the configuration file of INetSim is in this location. Just copy the location, jump back to Remnux, and we will be using Site editor. Site editor, and here. Okay, and we need to modify some things here. First of all, make sure that you have enabled the start service DNS, start service HTTP, and start service HTTPS. It's necessary. And after that, you change the service bind address to address 000. Okay, save. Oh, I forgot one thing. I forgot one thing because we have these two virtual machines. We need to have these two virtual machines, the Windows VM victim and Remnux, to be connected together. So if you check it, I already set that network adapter, I have only one enabled, is HostOnly Adapter. The same is for the Remnux. Yeah, the same is for the Remnux. You can see HostOnly Adapter, the same adapter as the Windows victim. But HostOnly Adapter in Windows, it's absolutely okay. It's basically, it's up, yeah, it's defaultly up. The address is automatically assigned, but in Remnux, it's Linux, so it's quite more strange. So you have to basically enable this interface and assign IP address. So let's jump to the Remnux and run our terminal, new window, sudo, and you can see here devices network, that in VirtualBox the network adapter is enabled, but if you check the if config, you can see only localhost is running, maybe -a, and you can see here is our required interface. It's down and there is no assigned IP address, so copy that, copy, and if config, let's change the state to up and assign some IP address. So if config this interface and IP address 192. For this exercise, we'll be using IP address 192.168.56 and 10. Let's check it again. And you can see that this interface is running, it's in state up, and there is assigned IP address 192.168.56.10. Nice, correct. And that's all what I forgot. Close terminal and jump back to INetSim. So basically we change the service bind address, and first here don't forget to enable start service DNS, HTTP, and HTTPS. If you have it commented, just delete the comment. So service bind address 0000, and we just need to modify the HTTP bind port. HTTP bind port, I think. No, DNS default IP. DNS default IP should be this one, so it's correct. The one we just assigned to Remnux. And now HTTP bind port, we need to change it to 8081. This is basically port the INetSim will be listening on. Yeah, and to this port you will be redirecting all web HTTP traffic from Burpsuit to this port, and the HTTPS traffic we will be redirecting to this port. We have to change it to 8443 and HTTPS here enabled. Why we have to change it to 8443? Because I want to ports like 443 and 80 will be used by Burpsuit, so we need to change it like that, 8443. And now we have to modify another thing. Basically we need to change the default fake file which will be served as a HTTP on HTTPS request, like a response body. So basically here is the default HTTP is the default fake file, but we need to change it, and we need to change it because we want to serve basically encrypted LokiBot this file. I already prepared it. It's somewhere here in a download folder. Yep, and here is the file. So basically what we need to do, we just need to change this line, and we can just copy it from here. You can see HTTP as default fake file, and this one. Copy, and what is here, you can delete this one and paste. And you can see here that here is the file name, and here is the MIME type, and this is very important. Don't forget the MIME type. I get the MIME type because MIME type is quite easy to understand that this is some kind of binary, and I also got the MIME type from the original HTTPS request from the malware when it was runnable and active. So here it is. I think that's all, but what we forgot is that this file, encrypted LokiBot download Google Drive.bin, which I have in download folder, has to be in specific folder. And for the INetSim, the folder is var lib INetSim HTTP fake files, and here. So basically copy this command, and this command will copy the file from the download directory to the directory necessary for INetSim, where the fake files are located. I'll copy it because from the configuration file here is only the file name, and the INetSim is looking for in the specific folder. You can save this configuration file because it's there is already everything set. What we need to do, and just go to downloads, open terminal, sudo su, and copy the command, paste. You can see copy, encrypted down this file to the required folder for INetSim. Yes. And the last command for INetSim is basically changing the permission for this newly copied file, because it needs to be readable for the INetSim process. So you can change the permission to 777, it doesn't matter, but it needs to be readable. Okay, and that's all for INetSim. Maybe we can close it, close the terminal, close this window, and clear, and we can jump to Burpsuit. So run Burpsuit, and we need to configure the Burpsuit to redirect the traffic to already set ports where the INetSim will be listening. So let's run it. And after we configure it, you can see the configuration here. Burpsuit, we just need to jump to Proxy listener option and set here these options. And I will explain the support invisible proxying option. I don't want to help, accept. Temporary project, next, default, start burp. It will start the Burpsuit. And basically don't forget to run it as a root, because we need to listen on all interfaces, so the root is required. And yep, here it is. Okay, and jump to the proxy, and here the options, and you can delete this one, remove, and we will be adding 3 entries. First entry will be bind to port, so Burpsuit listening port will be 443. All interfaces, jump to the request handling, basically where we want to redirect this request, which are going from the Windows VM to the 443 port on all interfaces. We want to redirect it to port of INetSim, so request handling, and redirect to localhost and port 8443, if you remember. And here is the option support invisible proxying. Here is another option. You can see default option for certificate, generate certificate per host. It's basically default settings, and this is basically the capability of Burpsuit we need to be able to generate its certificate on the fly according to the required or requested host. So it's okay. So jump back to request handling and check here the option support invisible proxying. Click OK. We just yes, we want to listen on all interfaces, and this is correct. What is the invisible proxying? Basically, if you check the Windows machine, and here is the proxy setting. Yep, you can see here is the internet options and LAN settings, and here proxy server. You can configure proxy server or automatically detect settings, but these are system proxy settings. If you configure here the proxy, the system will be proxy aware. What does it mean? All web traffic will be redirected to the proxy server, to the IP address of proxy server, and the structure of the web request are different if the system is proxy aware or if not. Because if there is a proxy on the network way, on the network root, and the system is aware of the proxy, the web requests are starting with the connect request, where the authorization can be performed and other stuffs. So there is some connection to proxy, and all web requests are going through proxy server, like meant in the middle, and the proxy server is redirecting to the destination, the web request, and other stuffs. So basically, if the system is proxy aware, the web requests are structured differently and handled differently than if the system is not proxy aware. But what is very important here, that in this case we need to have okay, we can configure that the proxy is on the IP address of Remnux and other stuffs, but this is very important option in most of the malware samples, because many malware samples are performing web requests and or communication performing the web communication via Windows API. And Windows API have options to configure that you want to proxy bypass. What does it mean? So basically, many malware are performing proxy bypass. So if you have configured the proxy on your system and your system is proxy aware, the malware can still bypass these proxy settings and redirect all traffic to the default gateway. So it's just ignoring the proxy server and trying to going directly to the default gateway. And these many malware samples are doing that. So basically, if your, for example, fiddler will be listening on localhost, and there will be system settings for that, be careful, there is fiddler, there is proxy settings, so your browsers will be function like that all the traffic will be redirected to the fiddler and other stuff. But the malware, if it's using Windows API and it has specified that it wants to proxy bypass, it just bypass the fiddler. It just direct the web request directly to the gateway and it goes to the internet and other stuff. So basically, this is very good option to use in Burpsuit. Very useful in malware analysis. So I want to add other entries. You can see it here. We need to also redirect the traffic from port 80 to 8081, again to INetSim. Again, check the box support invisible proxying and interface 8080 or interface port 8080 for downloading the certificate and import this retrusted. Yes. So jump back to Remnux and at another one, bind port will be 80. All interfaces and request handling will be 8081. The INetSim port, or sorry, this is the host, localhost, and port 8081. And support invisible proxying. Okay. Yes. And basically, the invisible proxying, Burpsuit basically works like it's just parsing the raw requests which are not proxy aware, and basically it's able to process the web traffic as the system would be proxy aware. So very tricky and nice feature from Burpsuit. At another entry, and here is bind port 8080 or interfaces, and we don't want to handle this request because it's just only listener for the Burpsuit to download a certificate from the Burpsuit. Okay, yes. And this is it. This is it. Basically, 443 port listening on Burpsuit will be redirected to INetSim 8443, and port 80 will be redirected to 8081 of INetSim. And INetSim will be basically serving the responses for these requests. And we already specified that on the HTTPS request, the INetSim will serve our encrypted LokiBot payload. And that's all. Let's this is already set. Go to HTTP history, and here is a default filter, so just change it to be able to view all the HTTP traffic. Just show all, because you can see that there was filtered binary files, and in this case we need raw binary files to see. Okay, and now we need to run also the INetSim. INetSim, and yep, everything is working, no errors. Nice. Okay, INetSim is running, Burpsuit is running, and go to intercept and turn it off, because we don't want to intercept, we just want to see the traffic through the Burpsuit. Just jump back now, it's time. You can see that we already did all of these, and just we have to configure our Windows VM. Basically, we need to change that default gateway will be IP address of Remnux, and we need to change the DNS server will be again IP address of Remnux. After that, I will show you what to do. So jump to the VM, go to the Network and Sharing Center, local area network, properties, TCP/IP. You can see that we have here only one network, yes, and we have to configure it statically. So the IP address will be 192.168.56 and 7. Yep, default gateway will be 192.168.56 and 10. And the same IP address will be for the DNS server, the IP address of the Remnux. 168.56.10. I should confirm it. Here, new terminal, window. Here you can see 192.168.56.10. Okay. 192.168.56.10, 192.168.56.10. Yes, this should be correct. And okay, and yep, choose the home network, close and close. Now we can try to ping it. Try to ping the Remnux IP 192.168.56.10. Pinging, and we have replies. Nice. We can try another thing, because if we properly set the INetSim, there should be already successful answers for DNS requests. So we can use NSLookup, and for example google.com, it should be responding with the IP address of the Remnux IP, and you can see here the address is the Remnux IP. We can try to, for example, github.com, and we can see we can try, for example, absolutely some shitty things, and you can see again. So whatever DNS, it will be it will respond with the IP address of the Remnux. So everything is related to Remnux. Nice. Now is time to do another thing, or try. If everything is correctly set, we can try to download our served payload we already configured for HTTPS. So we can use, for example, PowerShell as a for web requests, and we can do something like this: request invoke web request. There should be some HTTPS. And drive.google.com and something. Enter, and we can see what we got. I can now say you what we got. We basically get untrusted. Yeah, because the underlying connection was closed, could not establish trust relationship. Why? Because we get certificate for drive.google.com from the Burpsuit, but we are not trusting the Burpsuit certificate, which basically was used to sign a certificate generated on the fly for drive.google.com. So we have to download the certificate of Burpsuit certificate. And if you remember, we configured the port to be 8080. So 192.168.56.10 and port 8080. And we can see Burpsuit certificate, authority certificate. We'll save the file, which is the certificate, and we need to import the certificate as a root trusted. I will show you how you can do it. Because with this certificate, all dynamically generated certificates on the fly for example, google.com, github.com, this certificate will be used for signing. We have to trust him. So double click, open, we will import it, install certificate, next, place them in the store, browse, trusted root certificate authorities, okay, next, finish, and here, yes, we want to import it, import successfully, okay, just close it and now try it again, and it should work. Yep, it looks that it worked, but check it in a Burpsuit, and here is something here. Here we can see that the PowerShell was performing GET request to this URL and to this host drive.google.com. You can see the user agent PowerShell, Windows PowerShell 5.1, and response is yep. The response is from our INetSim HTTPS server, and you can see that content type is application octet stream, and here is the body, and the body is our served encrypted LokiBot payload we specified in INetSim configuration. Nice, so it looks like everything is working. So we can clear everything, clear history, yes. Jump to the Windows VM, close the PowerShell, and just I will be running also the process hacker to check something, and also I'll be running the Wireshark. I want to show you something. And here is the local area connection to this one. Okay. We can close it now or minimize, and now we can run our sample. Basically the GULoader downloader, which will be downloading the encrypted LokiBot payload from the drive.google.com, basically our spoof host from Remnux. And INetSim as a drive.google.com will serve the encrypted payload of LokiBot. The GULoader will decrypt it, run the LokiBot, and the LokiBot start to communicate to command and control server the direct IP connection. We will all see in Burpsuit. Let's run the sample. And here is the process hacker, and check here the network. Because in network we will see that there was some network connection and downloading the encrypted payload and other stuffs. Okay, these are prepared tools for next steps, but here you can see it's running, and it's basically the GULoader is decrypting stuffs and performing some checks, and now it spawned a new process, and basically this process will try to download the encrypted LokiBot, decrypt it, and run it. And you will see the network total bytes here. And basically we are using also the INetSim for the LokiBot command control server, which will be still responding with 200 OK for the malware server for the LokiBot, and the LokiBot will be still running, because if there is no connection to the command and control server, the LokiBot will end itself. But we are establishing the connection and still responding to the requested command and control server from the LokiBot. So you can see here is network total bytes, the payload was already downloaded. So now we can suspend it, suspend the process, okay, because the LokiBot should be already decrypted and running. We can stop the capturing in Wireshark and check what happened. First of all, we can see client hello TLS connection, and you can see that here is the communication to drive.google.com performed by the malware sample. And you can see here is the server hello response from our Burpsuit, and you can see here is the certificate what the Burpsuit served. And in the certificates you can see there are two certificates. One is the certificate authority certificate, and one is the certificate dynamically generated on the fly for drive.google.com. And here is the certificate. You can see signed certificate, and you can see issuer is Burpsuit, And as we already imported the Burpsuit certificate as a root trusted certificate, our system is trusting this certificate signed by this issuer. And subject of the certificate should be drive.google.com. Nice. So basically, this is the certificate for drive.google.com signed by the Burpsuit certificate. We are trusting this certificate authority. So we are trusting the certificate of drive.google.com. Everything is working. And here, here, you can see some posts to change URL. And this is basically the communication of LokiBot to command and control server. And that's all. I will show you all in Burpsuit. Jump to the Burpsuit, the Remnux, and here. And you can see here everything. You can see here everything. Check it here, and you can see here is the communication of the GULoader to host drive.google.com. Here is the user agent, and here is the URL. You can see UC, export, download, ID, and other stuffs. Okay, and here you can see the response from the INetSim simulator. And this is the encrypted payload of the LokiBot. And what you can see here is basically communication of the already decrypted and running LokiBot to its command and control server. And you can see it's trying to post some data like computer name, some domain or host, and some data. We don't care about this data more, but yeah, here is the communication, and you can see the responses are we didn't configure the response for this domain, but we can configure it in INetSim very easily, but we don't need to. You can see that INetSim is just responding 200 okay, and it's enough to hold the connection still established, and so the LokiBot will not end itself. Nice. So we can see everything here. So we can jump back to Windows VM, and as the LokiBot sample should be already decrypted, just go to memory and try to find read, write, execute, or execute protection memory with executable protection, executable permission, and it will be some, yeah, here it is, 400,000, and you have to save this memory to some location, but be careful, because what you can see here, this is very strange. Check this strange protection. If you try to read it, you can read it because there is some NA, some strange protection. You can basically change the protection in Process Hacker to 040 OX40 to be page execute read write. Okay, and now you can read it. And this is very strange because this is the most required memory address space, because there are all information, all strings related to password stealing, semantip, and other stuff, passwords, mail, blah 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 blah, password, pop3 server, blah blah blah. So basically, this is the most important memory address space. But we can just right click, save, and save all the memory range to the location. I already prepared tools for repairing it. Tools and save. And we can terminate this process. Because we don't need it anymore, just jump to tools, and I have it here. This is all the memory range, but we need to repair it. We need to unmap it because the process the module was virtually mapped. So we need to virtually unmap it. And for this purpose, as in previous part, I will be using punmapper. It's a small utility, but very useful. Made by HasherZ, reverse engineers. So use it, love it. punmapper, check the help, and again punmapper in would be this dumped memory range. We have to specify the base, and base address, if you remember, was 400 OOO, and output will be LokiBot unpack.exe, and correct. Okay, and you can see it here, LokiBot unpacked. Just check the file in pbur. You can see that the imports are correctly repaired. Yep, nicely repaired. Yep, some ordinals. Okay. Yep, sections. Nice. Everything is correct. Okay, and we can also check the strings that we successfully unpacked this sample. And you can see it's very nicely readable what this sample will be probably doing. Yeah, you can see some Windows API, basically NT native APIs. You can see some strings related to password stealing, processing SQL, and other stuffs. Yeah, Mozilla and other stuffs. But this is not subject of this part. Okay, so that's it. That's probably all I wanted to mention here. Yep, check Burpsuit. Yep. And basically this sample repaired, unpacked, is prepared for the last part. So please stay tuned, because in the last part will be probably the most interesting one. Maybe you are waiting for it, because it will be all about reversing, dealing with API hashing, decoding stuff, performing the initial malware analysis using. I will be using some special tools and telling you some tricks and how you can do it in fast way and other stuff. So basically we have all prepared for the last part of LokiBot analyzing, the main part which will be focused on reversing. So I hope you enjoyed it, and see you next time.